All right, so 7.1, still talking about vectors as forces now. And I just want you to bring you back to this little diagram over here, which you've probably seen a similar diagram when you did trig in grade 11. You can look back at my trig video and you'll see how it relates. So if I have some random force, vector f, going across a Cartesian plane or in whatever direction, we can break this vector up into components, and those components include the y component and the x component. So I wrote that down over here. Vector f can be broken up into its vertical and horizontal components, vector fy and vector f of x. So if you take a look at this, if this is the vertical component, I mean, this is the same as on this side, right? So I can just draw this. This is also the same. And if you remember from trig, if I want to figure out the vertical component, if I know the angle, this is just the opposite over hypotenuse. So really, the vertical component of any terminal arm when you're dealing with trig in a unit circle, but any vector is just going to be the sine of that angle. So this is going to be sine theta of that angle. Okay, and I have to multiply that by, I'm going to write that in front actually. It's going to be vector f sine theta. Okay, because if you think of it, SOHCAHTOA, sine theta is opposite over hypotenuse, fy over f. And if I want to solve just for that vertical component, I just multiply vector f over there, and I get vector f times sine theta. Likewise with x, this is the adjacent side. So the adjacent is fx divided by f. Adjacent, hypotenuse. So if I rearrange that and solve for just the horizontal component, I get vector f cos theta. So these are my two formulas to break up any vector into its vertical and horizontal components, which is extremely, extremely necessary. So let's take a look at how we do that in a word problem. So over here we have Kayla pulling on a rope attached to her sleigh with a force of 200 newtons. So let's say I have a sleigh. That is my sleigh. I'll even color it in. And the rope is being pulled with a force of 200 newtons. So let's say it's going up like this. This is 200 newtons. And this is, someone pulling the sleigh. If the rope makes an angle of 20 degrees with the horizontal, so anytime you see horizontal, just maybe do a little dotted line because that's the angle in question right there. We want to find the force pulling the sleigh forward, and we want to find the force that lifts the sleigh. So what we want to do is we want to break this up into its components. Now this is a right angle, right? Because horizontal and vertical make a right angle with each other. They're perpendicular. So if I want to find the vertical component and the horizontal component, I just basically use these formulas, right? So I can say, well, pulling forward is the horizontal component. So vector f of x in terms of the horizontal component is just going to be vector f cos of 20. And I can then say equals, plug that into your calculator, and that's the force in newtons that you're going to get. I don't have a calculator here, so it doesn't really matter. Anyone can plug that into the calculator. And likewise for the other side, for the vertical component, it's going to be 200 sine of 20. And you can say now the force pulling the sled up is going to be this many newtons once you plug that into your calculator. And that's how we break up a scenario with a force into its two components. Okay, so now moving on to a different example that has multiple, left, right, multiple ropes besides one on a sleigh, verbal diarrhea. So example 2 says a mass of 20 kilograms is suspended from a ceiling by 2 lengths of rope. So here we have a 20 kilogram object suspended from a ceiling with 2 pieces of rope. And they make angles of 60 and 45 with the ceiling. There it is. Determine the tension in each rope, the tension. So first of all, this 20 kilogram object is pulling down, so that those tensions are pushing up. Those forces are acting on that rope. Now, the first thing you have to know how to do here is change kilograms into a force. So if you don't know how to do that, 20 kilograms We always multiply by 9.8 on Earth anyways, and this tells us our R value, so 196 newtons. So this 196 is really this vector force right there. Okay, because we don't like kilograms, we need to know exactly how many newtons of force, and it's always multiplied by 9.8, so don't forget that. Now, this is our position diagram, and we're going to change it into vectors. So what we do is I'm going to take this vector and just put it on top over here so I can add them. Okay, and as I do that, this force that's pulling down is going to be the addition of the two. So you can see that here. I can say T1 plus T2 should be equal to vector R, like we have over here. Now let's take a look at how we can move these angles. If I take this and put it up here, I'm going to have a 60 below the horizontal and a 45 above the horizontal. So I'm just going to draw a dotted horizontal, and I'm going to say this is 60 and this is 45. Now if I know this is 60 because this is a right angle over here, I know this is going to be 30 and that's going to be 45. And I have all my angles. Done. So what am I looking to solve? Well, I want to solve for the tension in the rope, either T1 or T2. I mean, both really. So I'm going to use triangles in here to try to solve for that. So for instance, get a different color. If I want to solve for T1, let's say, I'm going to have to use sine law for T1. And T1, if I'm using the sine law, is going to be over sine 45, and this is going to be equal to 196, which is R, over sine of 105. Okay, so this entire angle in here, these are buddies, right? So 105 and the R, they're going to be in one ratio, and the T1 and that 45 across the triangle is going to be in the other ratio. So now all I have to do is multiply 196 by sine 45, divided by sine 105. I'm going to get the tension on this rope is 143.48 newtons. Okay, now I can do the exact same thing for the tension on the second rope right there. So I'm going to do the same thing, sine ratio. I'm going to say, well, the tension in this rope divided by sine 30, so this tension divided by its opposite angle, is going to be equal to the same angle. Same ratio. Sine 105. I multiply the sine 30 up here, and I get the tension in the second rope is going to be equal to 101.46 newtons. Okay, so I created a position diagram. I've converted it into a vector diagram where I can show the addition of the vectors. I've made a statement, and using that statement, I mean, these both equal 196. I forgot to add that in. But if I have one side length on a triangle in every angle, I can find the rest of the side lengths using sine law. Okay, so I'm missing T1 and T2. The question asks find T1 and T2, the two tensions, and I did that. And this is done.